In this video I'll be showing you how to make a pretty simple platformer camera. It's a little more advanced than your typical follow the player one though. This will support aiming ahead, so as you can see the camera's to the left of the player. It will support micro movements, so you can move in place without the camera moving, smoothing from one side to the other, as well handling up and down movements, and a couple other things which allow tweaking the settings so you can get it to how you like. So here's an example of the camera, what it looks like before we begin. Alright, I'm going to go ahead and start by removing the script we have, and we'll make it from scratch. Okay, so I need to make a utility script that I just deleted before starting this video. It's something I'll use. It's pretty simple. I'm going to call it float range. So create a new script, call it float range. Go ahead and open that up. Ignore all these errors. This is related to the previous one that I deleted. And I do not need this to be a mono behavior, so I'm going to go ahead and get rid of all this stuff here. I don't need any of this. I will need to make it serializable so that I can show it in the inspector. So I'm going to go ahead and do that now. And I only need two things from this. I need a minimum range and a maximum range. And I'm going to make this into a constructor. I did that, by the way, by highlighting and then pressing Control and then period, and there was a generate constructor option. I like having this on top, so I'm just going to move it real quick. Alright, so that's all I need to do to this file. So I'm going to go ahead and save and close out of it, and then go back to Unity. Well, now for the actual camera itself. I'm going to jump into a folder I already have set up, but you can of course put yours anywhere. Make a new script. I'm going to call mine multi-directional leading camera. It's a bit long and kind of generic, so you can of course name yours whatever you like. Okay, so I don't really need these two namespaces. I'm only going to use a Unity engine. I do expect to put this on the game object where my camera is, so I'm going to require the camera component. I'm definitely going to need a target to follow. So I'm going to make a serialized field here, and I'm going to put in a transform. I'm going to call it target transform. So this would be our player. Whenever you set this up for your game, you might need to be able to assign this for respawns or whatnot or whatever, but for this example we're going to hard code it. I'm also going to want a couple private variables. One to start is a reference to the camera. So I'm going to go ahead and set that up now. I'm going to be very basic with these notes, so you don't have to spend too much time on them, but I'm going to put them there just in case you'd like to read them. Okay, so let's add in awake, where I am going to get the camera reference or set it. I don't think I'm going to use start, and I'm not going to use update, but I will be using late update because I want to move the camera after the player calculations have already been made. Okay, so I'm going to make a method. I'm going to call it follow target, and it's going to do exactly as that states. And then I'm going to make another method that's called we'll call it move to goal, and it will expect a vector 3 called goal, and this is going to be the part that actually moves the camera. So this will set to position, and this will move it to that position. Also, I think under awake I'm probably going to go ahead and set the position of my transform to match the target. But I'm going to keep the position of the camera on the Z so it doesn't go right up to the target. We want to keep the same depth, of course. And under late update, let's go ahead and put follow target. If you haven't already, save your script. Okay, one thing I definitely don't want to do is try to follow the target if the target doesn't exist. So I'm going to do if target transform is null, then just exit the method. I don't think I want to do calculations either if my target hasn't moved, so I'm going to set something up for that real quick. I think I will do add a new private here, and I will set it as a vector3, and I will call it as last target position. This would be position of the target after last frames calculations. Okay, so exit if null, and let's only do calculations if target transform position doesn't equal last target position. I'd like to get the direction of the target. This is so that I may see what direction they're traveling, so I know if they change the direction I might need to swap the camera offset, or how far it's leading in front of the player. So I'm going to do float direction equals target transform dot position dot x minus last target position dot x. So actually I need this to be -1 or 1 only. So I'm going to make sure I set it to a sign so it's only -1 or 1. One thing I should probably make before I continue are 2 float variables for the coordinates I will be using if I need to update the camera's position. So I'm just going to call that float x and float y. I made this script already and I went through all the troubleshooting, so I know I'm going to need a way to determine if the player changes directions and if they're inside what I call the floating range or bounds, basically indicating that little area that they can move left or right without the camera moving. So I need to actually make a variable to indicate the bounds, and that's going to be a private. So I'm going to do private, and it is going to be a float range, the class we just made, and I'm going to call it horizontal. We'll say floating bounds, and I'm going to set that to null by default. And of course it is going to be null if you just declare it, but I tend to have the habit of specifying. So this is going to be bounds in which we'll say bounds where the target can move freely horizontally without the camera moving. I'm going to jump back down. So I need to add an if statement which will check if the bounds are null, and if they are null, do I need to set them? So I'm going to do if horizontal floating bound equal null, and I only want to set the bounds if the direction changes. So if the player is moving in the same direction, I have no reason to create a left or right pivot. But if they do change direction, I want that little pivot area for them to fine tune or adjust their position. So I'm going to do if horizontal, if direction doesn't equal, looks like I actually need a last direction variable. So I'm just going to type it in. If direction doesn't equal last direction, I'm going to do a little cleanup here. So I'm going to rename this to horizontal direction. And again, with a control period, brings up this rename option. And I'm going to do doesn't equals last horizontal direction. So I'm going to make this a variable, and it's going to be a float. So I'm going to go ahead and go back up here. Private float last horizontal direction. And this is last, or let's say direction of the target after last frames calculations. There we go. So now I know if that there is currently no horizontal bounds, currently no horizontal floating bounds, and I only want to potentially make one if the direction has changed. If direction has changed, make new floating bounds. Go ahead and save once you get all that done. I'm going to make this a method just to keep it a little bit cleaner so there's not too much logic here in one method. So I'm going to do private void set horizontal floating bounds float target x. So this is where the target's going to be at currently. And float target direction. So this is going to make bounds based on which way the target's moving, as well their current position. So I need the half width so I can go from the center in either direction, left and right of the pivot point. So I'm going to do float half floating width equals horizontal. Looks like I don't have a variable indicating how far the player can go left or right, so I need to set that up. So I'm going to go up here to the top where my serialized variables are, and I'm going to make one. So serialized field, private float. I'm going to call it horizontal floating width, and I think I'll set a default of 1.5 f, so 1.5 units. Distance, player can travel from center point for horizontal floating bounds. Not a very good description, but whatever. So I'm gonna do that and go back to that. I'm gonna select my horizontal floating width and divide it by 2 to get the half floating. So now I need to get the middle of that point. The middle is not going to actually be where the target stopped. It's going to be where the target stopped minus the direction times half floating width. So let's say if I'm going left to right, this is kind of a vague demonstration, I know, but let's say I'm going to the right, my target's right here. So I'm going to actually set the bounds right here, so I know if it goes outside this region or outside that region that the bounds will clear and the camera will begin following it again. So that's going to be middle equals target x plus target direction times half floating width, and then I'm going to make a new bounds off from this. So I'm going to do horizontal floating bounds equals new float range, and do middle minus half floating width, middle plus half floating width. So it's just setting the minimum and maximum value. I'm going to call this, say, creates a horizontal floating bounds. If you want to fill this in, feel free, but I'm not going to at this time. So now I need to go back right here, and I'm going to go set horizontal floating bounds. And I'm going to pass in the target transform.position.x as well the direction they're traveling. So also whenever they change direction, I'm going to want to reset the smoothing, so how quickly the camera catches up, because how this works currently is as they move, the camera starts off slow and then it speeds up and then it starts to slow down again when it gets near the end. And if we don't reset the smoothing value, it's just going to snap from either side. So that's something we have to do when they change directions. We don't actually have any smoothing variables currently set up, so we got to go ahead and do that now. So I'm going to go up top. It's going to be a private variable. I'm going to call it is a float. I'm going to call it current smooth time. Time to smooth damp this transform to the target's position. And how this is going to work is this variable is going to increase and decrease, in which will generate that smooth movement as we pass it into smooth damp. We're also going to need a base time to start at, so a time to reset it to, basically the maximum smooth time, and we're probably going to need one for the minimum smooth time as well. So let's go back up to the top here. I'm gonna make a new header. I'm gonna call it smoothing, just to kind of separate stuff. I'm gonna make a new serialized field. I will call this one private float smooth time base. I'll say half a second. So that should be pretty good, but you can adjust it once you get it done, get to play with it. I'm gonna make another one. I'm gonna call it minimum smooth time. I'm gonna set this to 0.5. This can be 0 if you want, but basically how this works is if you want the camera to always fall behind the player, then keeping this anything above 0 will cause that. Not necessarily far behind the player, but just a little bit, so that whenever they do stop, it's not an abrupt stop with the camera as well, but the camera will rather kind of slowly ease into its destination. And the last one will be the decrease rate, so how quickly the smoothing time will go down as the camera progresses. So I'm going to call that private float smooth decrease rate, and I'm going to set that to let's say 0.25 as a base. And this honestly doesn't need to be really any lower than 0.01 or 1. If you set it to 1, then you're probably not going to have any smoothing at all, but just as an option. So let's go ahead and add some comments real quick. How quickly to decrease smooth time from smooth time base. Lowest value smooth time may reach. And lastly, oh, it's not giving me the summary option because of this header here. Comment that out. There we go. Default time to smooth damp to target position. Let me go ahead and uncomment my header. Okay, so I think that's it for smoothing. So let's go ahead and go back down here and reset smoothing time as well. So current smooth time equals smooth time base. And save your project or class if you haven't already. That's all we have to do. If there are currently no floating bounds, we just have to check if one needs to be made, and if so, make one. Now we need to handle the logic. If there is a floating bounds, check whether if the player has exited, or rather the target. So there is a floating bounds. So I'm going to do else. And now this is just a simple position check, basically to see if they're outside that float range. And if they are, then we just clear the floating bounds. So we're going to do if target transform that position.x is less than horizontal floating bounds dot minimum, or if the x position is greater than the floating bounds dot maximum. And we just need to clear the floating bounds if that's the case. So if target is outside the bounds, then nullify floating bounds. So now I need to go a little bit below, and this is where we will set the x variable, which I'm going to actually rename. I'm going to rename that to goal x, and I'm going to rename this one the goal y, just so it's a little more clear. So how we set the x is going to be dependent on if there's a floating bounds or not. It's actually going to be really simple. So set goal x if there are no floating bounds. We're going to set the goal x to the target's position of x plus the overshoot times the moving direction. So that's simply goal x equals target transform that position of x plus we actually don't have any overshoot variable in here, so I'm just gonna put something in which we'll put up top in a second. Horizontal overshoot, and this is gonna just be the part that leads the character, so leads the camera in the direction that the character is moving. And I'm gonna multiply that by horizontal direction. So I'm gonna take this variable here and copy it, or it's not a variable yet, but it will be in a second. And I'm gonna make this adjustable, so I'm going to put it as a serialized field, private float, horizontal overshoot, and I'm going to set this to 1.5f, distance to travel past the target in the target's moving direction. And if I go back down, that should be good. Okay. So there's two ways you could handle this if that the horizontal floating bounds are not null. The first way is you could just keep moving on the targeted goal that's already set. So let's say if the camera is moving left already but it's not caught all the way up, and your character stops and goes right real quick and it sets the bounds, you can have it keep going left until it gets to the goal, or you can have it stop abruptly. I'm going to show you the part where it keeps going left to the goal first, and then show you the other option. You can set it however you want. It's only going to be one line difference, so it won't be too hard to go back to. Of course, though, we do need a camera goal variable to set, so let me go ahead and make a new private vector3 camera goal destination for the, or I'll say for this transform to move towards. I'm gonna go back down, and I'm just gonna say else goal x equals camera goal dot x. So that's simple. So we'll keep moving to the camera goal x if there's a floating bounds to basically complete its goal. If you want to stop abruptly, instead of doing this, you just use transform dot position dot x. So this will stop it abruptly. So let's keep that in mind. If you don't like the behavior, you can always change it with this one line. You know, why don't we actually just make this an option, so that way you don't have to worry about it. So I'm going to add these brackets because I'm going to drop another if statement in here. So I'm going to go up to the very top, and I will say make a new boolean. I'm going to call it stop camera on why don't we say on direction change. We'll call it stop camera on direction change. I'll set that to true by default. True to stop the camera horizontal movement when the target's horizontal direction changes. So I'll probably say stop horizontal camera. I'll just say stop horizontal movement on direction change. This is insanely wordy, and in practice I'd probably never actually use a variable this long, but I want it to be super clear what it does for you. So call it whatever you want. That's what it's just going to be for now. So I'm going back down to where we set our goal x, and I'm going to do if, I already can't remember the name of it. Oh, thank you IntelliSense. So if to stop it on direction change, we're going to just set it to the transfer position. Otherwise, we're going to set it to the current camera goal dot x. There we go. Now you have both options. Now that's it for the goal x. So we need to handle the y. In order to do that, the y is set up so that the camera doesn't move vertically unless the player reaches the very top or bottom of the viewport. So we're going to need something to specify that range for the bottom and the top. So I'm going to go back up here. I'm going to add, let's put it above. Let's put it right up here actually. I'm going to call this, it's going to be a float range, and I'm going to call it vertical viewport bounds. And I'm going to set it by default, I think, to 25, and let's say 65. You can change whatever you want. You're going to play around with it and find something that's good for you. So this is minimum or maximum, I should say, and maximum values the target must exceed within viewport space before this transform follows the target vertically. And again, you don't have to put these comments. This is just for you. So now we're going to use this new variable we have. And I think setting the y is much easier than the x. You don't have to do any of the smoothing. And I think it's a little easier as well because you don't have the floating bounds either. So first thing I'm going to do is get where the target is inside the viewport vertically. So I'm going to do vector2 target viewport position equals camera dot world to viewport point, and I'm going to get the target transform position. And this is simply where the target is within the viewport. This value will always be between 0 and 1 on both x and y, and the higher the value is, the more it is to the right or the more it is towards the top. So now I need to determine if the player is outside of its bounds or its region. So it becomes true if this transform needs to follow, and I'm just typing something for the boolean I'm about to make, needs to follow the target vertically. So that's going to be bool move vertically equals, and it's basically going to be if the target's viewport position is either below or above the bounds that we've set. So if target viewport position dot y is less than vertical viewport bounds dot minimum, or if target viewport position dot y is greater than vertical viewport bounds dot maximum. So it's not terribly complicated. It took a little to kind of figure out how I wanted it to work, but it's fairly simple mechanics. If this transform needs to move, so if move vertically, I'm going to add a couple spaces here. I'm going to need to know how far I have to move vertically. So I'm going to make a new float. I'm going to call it required units. And this is just going to be how many units we need to move in world space. I also need to get the camera height. So camera height equals camera.orthographic size times 2f. Oh yeah, you need to use an orthographic camera. Ha! Well, let's hope that's the case. Otherwise, you just wasted your time. So if the target is going up, which would be if target viewport position dot y is greater than 0.5, because remember how I said that 1 is going to be near the top. So clearly if it's above this, then the target's going up. Now the smart way to do this would probably actually not hardcode it like this, because if you use a lower value it might screw something up. So I'm going to actually do if target is greater or equal to vertical viewport bound dot maximum. That would be the smart way to do it. Now I'm going to do required units equals target viewport position dot y minus vertical bounds dot maximum. So basically it's going to see how much it is above the current bounds. And I'm actually going to drop the equal sign here. No, I'm going to keep it. I'm really indecisive right now. Times the camera height. So basically whatever percentage is above times the camera height is the pixels the camera needs to move up. So if it's below, we're going to do required units equals vertical viewport bounds dot minimum minus target dot y. So basically the same thing, but the opposite. And we're going to flip the camera height. And then we just have to set the goal y to the current transform position plus the required units. Oops, position.y plus required units. There we go. And if we don't need to move vertically, else we're just going to set the goal y to the current camera goal y, so the camera won't move basically, or it will update to whatever its current goal is y, but the camera is going to snap vertically, so ideally it won't move. And that's basically it for calculating which direction it needs to go up and down, left and right as well. So we need to build the goal from our values. So we're going to do camera goal equals new vector 3 goal x, goal y, and we're going to make sure the camera keeps its depth by using the same z position it already has. So now we just need to update the, we'll just call it last variables. So last horizontal direction equals horizontal direction, because you know we compare the direction up top and do things based on if it's changed, so this is important. And last target position equals target transform dot position, because we need to get the last position to calculate the direction. So outside that if statement, still inside the follow target method, we're going to call move to goal, and we're going to pass in camera goal. Go ahead and save. And I'm just going to put a couple comments here. Moves to the specified goal smoothly. And I'm going to go back up to this one. Set camera goal and issues this transform to move to the goal. Alright, so let's go back down to move to goal. This is going to be a relatively short method. We already did most of the work. First, if the transform position is already at the goal, we're not going to do anything. So if the transform position being this transform or the camera equals goal, we're just going to return an X as a method. Now we need to get the next X position. So we're going to do float next X equals math F. Math F, there we go, that's smooth damp. We're going to go between the current position X of this camera to the goal X, and we're going to pass in, oh, you know what, I don't think we have one yet. No. So like most smooth damps, you need the last value of whatever you're dampening. So we need to make a variable for that. So I'm going to comment this out just so it doesn't give me any errors. I'm going to go up to the very top, and we're going to make that variable real quick. I'm going to call it, it's a float, I'm going to call it last transform X, and this is going to be the last, or we'll say X position of this transform last after last frames calculations. Okay, so let's go back down to move to goal. I'm going to uncomment this. I'm going to pass in that variable we just made, so last transform X, and then we're going to pass in the current smooth time, which, if you remember, this variable will initially start off high, which will create kind of a nice little acceleration, and then as it gets closer to the end, it'll get smaller, which you'd think would make it move quicker, but it does in a way that it almost seems like the camera's not moving fast and coming to an abrupt stop. That eases it in nice and gently. Depending on your settings, you can actually tweak it to be more jerky if you want, so that's entirely up to you. So now we just need to set the position of this transform. We're going to use next X, and as I said, we're snapping the Y because the Y only changes if the player goes up or down, and we want to keep the player in frame without any smoothing. So I'm going to set the goal Y and the goal Z. And all we have to do now is just reduce the smoothing time so that it does increase as the camera moves more. So current smooth time equals max f dot max current smooth time minus time dot delta time times smooth decrease rate and minimum smooth time. So it chooses the maximum of either of these values. So if it's starting off at 0.5 and we reduce the delta time and ends up at 0.4, it's going to be 0.4. But if we reduce it so much that it's at like -5, it's going to default to the minimum smooth time, which is what we want. So let me just look over this real quick and make sure I didn't miss anything. Don't forget to save. I did actually find one issue. I need to reset the smooth time whenever the camera actually clears the floating range, rather than when the floating range is set. So I'm going to go back up to here under follow target where I set the current smooth time. And as you can see, it's set whenever I also set the floating bound. So I'm going to clear that. Going to just drop off the brackets so it looks like this. And then where I nullify the floating bounds, that's where I'll reset it. So I'm going to add the brackets back in and then just paste it below there. One other potential thing I found is I think I want to set this whenever I start the script, and also I want to set the camera goal by default to the transform position after I snap the position to the target. That way the camera doesn't drift off because the goal wasn't set. Now I'm just going to go back into Unity and set this all up. So I have my camera right here. It's just a normal camera. And I have a player right here. It's a very simple move script, nothing too fancy. You could literally just drop a cube in and then just drag the cube around if you wanted to watch it work. So I'm going to go to my camera again, where I'm going to drag on the script we just made. I have two because, like I said, I made it before and I just wanted to show you how to make it from scratch. So I'm going to drop my adventurer inside the target transform. Here's where you can adjust the viewport bounds. So if he goes above this, it'll snap. If he goes below that, it'll snap. I'm saying snap, but it's actually really fluid. You won't notice it. So again, we have the floating width, which let me just hit play and actually show you. Be a much better demonstration. So the floating width is how far he can move left or right without the camera moving. So this stop horizontal movement on, which you can't see all of, this is why I said this field name is ridiculous, on direction change, that's currently checked. So to give you an idea of what that will do is, let's say I move here and I stop. You see how the camera stops? I move and I stop and the camera stops. If I uncheck that, I move and I stop, it overshoots, which might be something you like. I just don't. So we have the smooth base time. That's how long it takes it to smooth from point A to B by default. Right now it's 0.05, so it's half a second. This is the minimum smoothness. So if I set this to like 0.4, it's gonna always be it's always gonna be behind a bit. So let me just show you here. This is how far the camera should be leading in front of me. But if I set it, you can see it's always going to be a little bit behind. So I usually keep this low. You can keep it at 0 or 0.05, and you have the minimum. Whoops, that was the wrong one. That was supposed to be the minimum smooth base I meant to change. And this is how quickly it decreases the rate. So if you set this up higher, it's going to snap in much quicker. You probably want to be looking at the top camera to get an idea of how it looks like. And I'm going to recheck that. Floating width, I'm probably going to actually set it to 1.25. Overshoot, 1.25. I'm fine with the viewport bounds. I'd probably actually, you know, I'm not fine. I don't know why I said that. And this is, you're done at this point. If you want to go ahead and end the video, you're more than welcome to. Nothing else needs to be done. I'm just kind of demonstrating how the fields work. So, like say if I bump this up, something crazy like 1, you can see how it really snaps in super quick. If you set this to a default, like the base to a lower base of like 0.25, then it's going to be even quicker. You can lower this down to like 0.4. And I don't really like that because it kind of has like it has like a snapping feel, and I don't like it. So my preferred is 0.5, the minimum of 0.5, with either 2.5 or 3 as the decrease rate. And I think that's pretty good, nice and fluid. You can't really even notice a transition at all. But you can use whatever you want. I hope you enjoyed this video, and of course, as always, leave questions in the comments, and if they're related to this video, I will definitely try to get back to you.